Good morning, everybody. I hope that you can hear me. I would like to welcome you on the EUMeTrain Weather Briefing. My name is Isabella, and I work at Institute of Meteorology and Water Management in Warsaw in Poland, so it will be here. But temporarily, I'm also a graduate trainee at EUMeTSat here in Darmstadt in Germany. But at the moment, I am in Norrköping in Sweden, where 30 people from Nordic countries are participating in NUMEC course, which is a course, but I asked some of my colleagues from different countries to assist me during this weather briefing. So now I would like to ask you, where are you at the moment? Okay, so we have participants from different parts of Europe. Perfect. And now we'll go to Carla Barroso in Portugal. Please, Carla, you can start.
Hello, good morning, everyone. So this is me speaking from Lisbon. So I will start with infrared, the 10.8 infrared channel for today at 6 UTC, overlaid with the mean sea level pressure forecast. And we can see there are several low pressure systems over this area, starting with this low pressure system to the north of the British Islands and Scandinavia, and another low pressure system over northeast of the Newfoundland, and also this low pressure system over the Atlantic, where I will focus today. And finally, I would emphasize this high pressure system over France that is somehow blocking the movement of this the high pressure system towards east and forcing it to move more to the north. And so the air mass RGB for yesterday at 12 UTC overlaid with the equivalent potential temperature makes the evidence that we had some activity yesterday over with some thundery showers over the Azores Islands, and so we can see these CB clusters over this region, and also the equivalent potential temperature shows warm air advection with these very high values moving towards north or northeast direction. And this is confirmed by the color of this air mass RGB, and so we have this green color, and we will see why do we have this so bright green here in this area. I recall you the recipe of the air mass RGB. So we had in the red beam difference between the water vapor channels 6.2 and 7.3 that gives us information about the moist at the high and mid levels of the atmosphere. On the green beam, we have information on the ozone concentration and therefore the tropopause height. And on the blue beam, again, the water vapor brightness temperature that is inverted. So we have values ranging from the highest to the lower to the lowest values. So a bit of theory now. So why do we have this this green color? So first, we should focus on the green beam, and so we have here very high contribution to the green beam that is given by this difference between the brightness temperatures in the 9.7 and 10.8 that is caused by the fact that we have low ozone concentration. And then in the red beam we have low contribution, since we have higher water vapor content at low levels. So the brightness temperature in the 7.3 is higher than the 6.2. And finally, also low contribution from the blue beam, because the water vapor is at lower levels. So we have this warm air with low ozone concentration and therefore high tropopause. And here we see different colors, and also here to red, and this gives indication of some stratospheric air intrusion in this region. And so why do we have this this red color for stratospheric air? So let's see. In this case, the contribution to the green beam is lower, since we have higher ozone concentration. Brightness temperatures from the ozone will be much lower than from the 10.8, and again a bit higher contribution now from the red beam. Water vapor is again at mid-low levels, and also again low contribution from the blue beam. So we have dry air with high ozone concentration and therefore low tropopause. So we are expecting that today, more to the afternoon, to have some showers to the north of Portugal and Galicia, and also some thunderstorms on to the north of the Gulf of Biscay. And that's all from my side. So have a nice day. Thank you.
Thank you, Carla, very much. You very nicely has already reminded us some properties of ERMAS RGB, and I think that it will be useful for everybody. Okay, now let's move to Germany and to Ivan.
Okay, good morning, good day to everybody. Looking at the window, I see sunny actually day with some post-frontal cumulus cloudiness. Very nice. I hope you can hear me. Can you give me yes if you do? Okay, I see some yeses. Good. You can also know how to use them. Well, this is the image. Somewhere on the earth I forgot to remove the marks of the countries. I'm sorry. It will be more interesting. But of course this is Germany, and my first question to you, we don't have too much time. I'll try to do some interactions, try to be quick, and place the star if you know which RGB this is. While you're doing that, I don't know if you understand the question. If you know what RGB this is, you can place the star. Of course, nobody can know which one is yours, so you can say also natural color RGB, for example, and nobody will have. Okay, while you're doing this, I will tell you that we see some whitish patches over the Germany. That means low clouds. Actually, this is image from the 7 UTC. Super cool clouds. Could be, yes. Below super cool clouds, there is there is a red area, which means probably the snow over Alps still. And here you have some more reddish patches, so it could be higher clouds. So we have the answers. Dust RGB, severe storm, night microphysics. So the winner is, of course, severe storm RGB. The season is starting, and I think we should start looking at it. So I will ask you the next question. What is the frequency that you use this RGB? Well, of course, it's not the best RGB for the first slide because it doesn't give you much information about the synoptics. Some information about low levels, but the main purpose is to detect the high clouds and really severe parts of the thunderstorms. Frequently, not so often. Okay, we have one big frequently, not so often, rarely, not ever. Okay, this is good. So I actually don't have time to give you an introduction to severe storm RGB, but there are many materials on the EUMeTrain web pages. So please go to EUMeTrain.org, and there you have many modules and actually manuals on how to interpret severe storm images. Okay. Since I don't have too much time, I just wanted to cover one nice, well, it wasn't nice, happening that happened 2 days ago in the North Germany, next to Rostock. Actually, one person died in Hamburg because of the severe winds and debris flying around. So from the images you can see it was total devastation of some parts. Trees uprooted and breaking into half, cars flying more than 50 meters, 150 meter per second winds more than, so it was quite severe. Synoptics for this event, of course, there is a big low with some small low center here, and well, if you consider it could be occluded part of this big system with the cold and the warm front. And there are many small centers here, and here probably, and of course this is an unstable area and prone to convective environment. What is important is this high jet stream along the conveyor belt along the cold front, which was responsible, you will see later, for the big high wind shear in this area. Here you can see streamlines, and if you pay attention to this part, you will see nice in the real image. This is actually Modi's image. You see a really nice outflow of cirrus in the cyan color, because these are really high ice clouds, so the color in this RGB is, of course, cyan. Okay, thermal front parameter gives some more information. Well, actually, the proof to what I mentioned earlier, the cold and warm front part and the occluded patch. Also, strong cold advection in this area, of course, and warm advection in the in the head of the system. I've looked at the STFX and their forecast for 5th of May, well, the day that this tornado event occurred, and I actually gave a warning for tornado. There were many uncertainties, so they just put number 1 there, so it wasn't really severe, big probability, but they actually placed the warning for tornadoes also. Why they did this? Of course, if you look at this map, you can see in the color patches you see the Cape. Of course, this Cape is not so big. Thank you for the box. And if you can see, it's maybe 800. It's not the huge Cape, but what drive this system and the development, convective development, was actually the shear, which you can see in the red lines, and the shear was over 25, 30, 35 some regions. So actually this system was or convective event was driven by the dynamical forcing of the shear more than a pure static instability of the atmosphere. Okay. Later on during the day, STFX issued another warning, well, discussion, mesoscale discussion, and they concentrated their focus on the Benelux country and the eastern Germany, northwest Germany. I'm sorry. Probably because many of the mesoscale models showed bigger instability in this area. But what really happened? I will just show the sequence of few slides, and you can follow this area, which is actually the convergence zone, which, I'm sorry, I need a highlighter. Convergence zone which was shifting in this direction, driven by the mesoscale forcing, synoptic forcing. So if I move to another slide, you will see that this system's, well, this area, instability area, moves to the east, and few of the, I'm sorry, I will do it once again. And you can see few of the cores of the thunderstorms in this area. One of these is probably connected to observed tornadoes in this area. So this is actually matching to the Rostock area. Okay, I hope everything was clear here. But my assumption was, and my interpretation, why it happened really in the West Germany, more than, well, east more than the northwest, is that we had the upper level low, well, the folding of the stratosphere in this region. And if you probably know that this is a PV anomaly, which often drives the strong convective activity. This is actually the high clouds of the thunderstorms in 6.2 water vapor image. And for the last slide, I will give you the first RGB I've showed. It's severe storm RGB, and what you can see in this region. I'm sorry. To take the laser pointer. In this region, you can see strong yellow signals. That means the small ice particles or the updraft of the system. Well, in the severe storm RGB, just to quickly mention, yellow color can be connected to a stronger updraft, which is in this case, but it can also be in the case of high base of the cloud, or also leak cloudiness, small ice particles in the leak cloudiness that can form, and the high leak cloudiness. And also polluted clouds have small ice particles, so they can appear yellow, but they don't have to be really convectively very active. So the yellow color comes from the small particles from 3.9 channel, which is included in the green, and from the really small difference of the red component at difference of 6.2 and 7.3. So this is a quick interpretation. So thank you, and we can move on.
Thank you very much, Ivan, for analyzing this dangerous event which took place in Germany. I hope that you have encouraged some of us to use also more often severe storm RGB images. So let's go to Croatia, to Tanya.
Hello everybody, my name is Tanya Renko. I work as a forecaster at Croatian Hydrometeorological Service. I work in office that is situated in our capital, in Zagreb. As you can see from our web camera that is on our roof, today in Zagreb partly cloudy, but in most of Croatia and the neighboring country, mostly sunny or partly cloudy weather. Same in Italy, Austria, Slovenia, Hungary, and clouds, mostly frontal clouds, are situated to the east and southeast. I forgot to mention this is air mass RGB. You have already seen this RGB, and Carla did some intro about it. And on the air mass RGB, I have overlaid a geopotential height of the 500 hectopascal pressure. So the second slide, I have put several air mass RGB images just to that you can see how the development of the situations went on from yesterday morning. And as you can see, this frontal cloud band is moving to the east. Now Croatia and neighborhood countries are mostly in the southwest and westerly flow. This trough will move to the east, and the ridge over eastern part of the Europe will decay during the day. Most of the convection that was going on yesterday were placed at the leading edge of the frontal cloud band. And this frontal cloud band, as already Ivan and Carla said, is connected to the low, which is over northwestern Europe. Today, as I said, this frontal system will progress east, and today's top region for organized convection, probably MCSs, as we already have some in these morning hours, will be in the eastern part, so Romania, Bulgaria, also probably Eastern Balkans and Aegean Sea. Initiation of convection will be frontogenetical forcing, but as you can see in this our morning hours, a low level. This part of Europe is reaching low-level moisture, and this is seen in values of dew point temperature. I'm sorry, I tried to zoom it, but these green numbers are showing dew point temperature, and they are already exceeding values of 5 degrees Celsius in some parts. Also, this rich low-level moisture will be during the day overlapped by steep lapse rates that are brought with southwesterly flow, and this will result in high Cape values, 1050 even more joule per kilogram Kelvin. Joule per kilogram. I didn't put here an image of deep layer bulk shear and low layer bulk shear, but the values that are expected here are significant. And so if we have overlapping of deep and low level bulk shear that are significant and high values of CAPE, we can expect some organized convection in this part of Europe. I will show some slides what happened yesterday. So yesterday most of the convection happened in Hungary in the evening hours. As you can see, here is one MCS over Hungary with cold ring on the top. This is enhanced ER 10.8 and it is used to discriminate cold cloud tops. On the next slide, I have put an image from our station, and this is high resolution visible, which is overlaid with ER color enhanced. This is so-called sandwich product, and you can see in Hungary very cold cloud tops, and this is probably an overshooting top here. On the next slide, I have put a product from nowcasting SAF, and it shows values greater than 30 millimeters of rain within an hour. This is a convective rainfall from nowcasting SAF. Also, you can see in radar image which shows reflection greater than 60 dBz, and this could be probably be some hail on the ground. Also, you can see lightnings which are placed ahead and along the cold front. And so yesterday evening we had quite an interesting convection going on, and as I said, we expect some today in the eastern part of and the southeastern part of Europe, and I think that this would be an agreement that even said that the convection season started already. This would be all from me. Thank you for your attention.
Thank you, Tanya. It seems that a lot of interesting convection events were in this region, so let's see what is in Central Europe. Barbara, you can start.
So, my name is Barbara and I work in Wrocław office, meteorological office, and I have to refer the report of the morning, today Sunday morning in the central part of Europe. And as you see, we have the occluded front in the Western Europe, and in the central part, there is the condition weather which we like the most. I think it's quite good, quite cool advection from the western part, from the Atlantic, and here we can see the temperature and geopotential at 850 hectopascal and in the surface level. So this advection of older but very nice air mass, Atlantic air mass, that's well visible. Here I have the natural color of RGB, and once again in the Poland and in Germany in the morning nothing should happen, and the weather is like we see and like we like, but when we see the next picture, I added the upper level jet and diversion and 300 hectopascal, so we can expect in the Czech Republic and also in the Czech Republic some development of the weather, and of course in the front of German, which will move eastwardly. But the weather conditions shouldn't be severe. And to tell truth, there is everything what I can say about the weather in the morning. So I should invite you to the interesting concert. But we have also what interesting severe weather one day ago or 30 hours ago. I think this picture will be the most recognizable picture for the people as this tornado in Bedstop near Rostock has happened. The streets full of tiles from the broken roof. And small revision after this, what Ivan said. European Severe Database noticed that there was 5 tornadoes, but this near Rostock was the most significant and is confirmed. I have the question for you. I present here 2 diagrams, and my question is if they are well described according to the dates. But, I wanted to mix the date, yes, to show, to activate, to focus your attention. But of course, I didn't change the dates. The dates are proper. The first diagram is from today morning, and the second one is from the Greifswald, so the neighborhood of the Rostock. 6 hours before the tornado occurred. And I would like to point this profile, vertical profile of wind characteristic for tornado occurrence. Perhaps there is not so big wind share, but we have seen this proper wheel of wind from the south east to the west south. And once again, the situation from 6 p.m. on 5 month. As we can see, the German forecasters made very proper warnings and forecasts of this phenomena. And once again, the same picture which Ivan showed yet. We can see that the jet stream was exactly in the left exit of jets, was exactly in the region of northern Germany when this tornado has happened. Yes, so it's according to theory, the upper level divergence support this convective weather phenomena. And once again, the picture with the upper level jet. My question was also where the thunderstorm can occur behind this yellow stars where tornado occurred. And of course, there was in the second part in the convergence zone before the cold front. We can see here very, very clearly the thunder detection and the temperature potential from the hours of tornado occurred. Thank you very much.
Thank you, Barbara. I hope that you could have heard Barbara more or less. Okay, let's try with Maile from Estonia. Maile, you can start.
Hello, everybody. My name is Maile Meius, and I work at the Estonian Environment Agency as a weather forecaster. Unfortunately, I couldn't find any recent picture of me. Instead of that, I found the face of Estonia watching the sea. So use your imagination and you can see the profile here. But now let's go to the more serious topics. First of all, we can see here the water vapor images from this morning. And here we can see the 300 hectopascal geopotential. We can see that over the western Russia is the ridge blocking the low system over the Norwegian Sea and Scandinavia. And also we can see the height of PV near the low centers. It's quite low. One center is here, another is here, and here is developing a new one. So if we look at the air mass RGB, so we can see here, I can use laser. We can see here the moist air, the frontal zone. Also in the 500 hectopascal, we can see the ridge blocking the low system. And the lapse rate is high values over the Scandinavia. So today there could be some showers with thunder. Next one. This is a natural color images. The first one is natural color image with the 700 hectopascal and temperature advection. We can see the occlusion which goes across the northern Scandinavia, Finland and Baltic countries. And here we can see the humidity over the 700 hectopascal. So there are a lot of humidity over the northern Scandinavia, over eastern Finland and eastern Baltic states, and also in the southern part of Scandinavia and Denmark. So next one. About the severe storm images, the big happening is in the southern part, and we have southerly flow towards the Baltic states and Finland, but we think that it doesn't reach to the Baltic states today because the airflow will turn to southwest, and then all this big convection area will go over the Russia. So these are observations and radar images at 6 UTC. We can see the narrow line of the frontal zone over the eastern Finland and the Baltic states, and also some cloud cover over the southern Scandinavia, which goes towards north. And afternoon there could be some showers with thunder. The weather is right now quite cloudy in northern Europe. Some clear parts are near the Baltic Sea at Botnian Bay, but mostly it's quite cloudy and lots of precipitation. But the air mass is warm, and by day there should be 18 degrees, even in the western part of Finland and the central part of Sweden. So it's quite warm, but in the northern part of Scandinavia and also in the Scandinavian mountains there are still lots of snow. For example, in northern part of Finland the snow cover is up to 70 centimeters, and in the mountains there are more than 1 meter snow cover still there. And that's all about the weather in Northern Europe. Thank you.
Thank you very much, Maile. Okay, I see that you can add some animation.
Yes, hello, this is Jochen from Germany. If you look at this animation, you will see that it is 5-minute intervals, so it's the severe storm or convection RGB from the rapid scan service. In this case it was Meteosat 8, the old Meteosat 8 doing these images. And as you can see, the tornado event in northeast Germany was the most prominent feature here on this RGB images. It's the only, let's say, yellow signal that happened during the day. All the other clouds are reddish, which means high-level ice clouds, but normal ice, relatively large ice particles, which is the normal situation. And so only in the area of Rostock, northeast Germany, where this tornado happened, the yellow color appeared. But it's not a deep convective storm, as Ivan said. This is relatively shallow convection, so not very cold cloud tops, not big overshootings. The storm of this type is more driven by the dynamics, the huge wind shear, the very dynamic situation with the PV anomaly very close to it, the secondary PV anomaly, and the jet stream, big wind shear. You could see the wind shear very well on the sounding in the lower layers, in particular from 0 to 5 kilometers. So I think it's a nice example of how you use the convection RGB in a real-time warning situation, that the forecasters in Germany should, if they look at this, they should have got warned by the yellow color and monitor the area closely. And actually the first yellow appears already 1 hour before the tornado hit Rostock area. So there was some lead time available for the forecasters if they looked at this loop. That's all from my side. Thank you.
Thank you, Johan, for this interesting loop. I thought that not all of you could have seen this animation, but you can see this recording later on the EUMeTrain website. I hope that you have enjoyed this weather briefing and you are encouraged to use more often different satellite images. Thank you very much, and I hope to see you in the next weather briefing next month. Thank you and goodbye.